Hey guys, welcome back to my garage. I'm getting ready to get back on the CNC mill project, installing the Centroid all-in-one DC motion controller. You've seen me do an overview on the overall project, putting encoders on my servo motors and bench testing the all-in-one DC to get it ready to install and to make sure that everything's functional. So the next step is starting to lay out the equipment cabinet. I've got a number of things that need to go in it. Let me use some pictures of some existing control cabinets that were already done to lay out my cabinet. We've got several things that need to go in it. Of course, the first one and the most important one is the all-in-DC motion controller. What I think I'm going to do with it is I'm going to put it down here in the lower right corner as low as it'll go. The reason why I'm going with that is so that all the I/O is accessible. It's on the top and on the left side of the all-in-one DC. The servo motors go on the right side, and that's enough room to get them connected. And then along the bottom, the DB9s, the encoders, will have plenty of room to get to. And I will cut an opening in the bottom of the cabinet, and I've got strain relief brackets. Centroid actually sells them, so that I can cut a window in there, and then when I'm done it clamps the cables and kind of keeps things dust tight inside the cabinet. So anyway, this is what we're going to do. I'm going to put the all-in-one DC like this, and then the spindled VFD is going to go up quite high like this. And I've also got another VFD that needs to go in here. This little guy here. So I'll keep these relatively close together. This is the spindle VFD. It's a Tico LF510. It'll take single phase in, 3-phase out. It's for 3 horsepower, 2.2 kW rating. So I'm fond of the Ticos. And then this little guy, this is a 1 horsepower Tico. And the reason why I've got it is because my mill has a power knee on it. I just push a button and it runs the knee up and runs it down. So I'm going to use that for the power knee, and it's going to reside in here. Also that needs to go in there is the power capacitor. This capacitor will take the 110 volts in and rectify it. So rectified, I think it's 1.414 is the multiplier. So you take your DC or your AC voltage incoming and you multiply it by 1.414, just call it 1.4, and that'll give you your DC volts out. My DC servo motors are 180 volt, I believe it was, Glentex. So they'll take the rectified AC just fine. It really simplifies things. I don't have to put a power transformer in here to get my DC voltage where the servo motors need it. So I'm real fortunate in that respect, so I don't have to put a transformer in here. I've got a relay here. It's actually let me see here. It's a 4-pole relay. I'm going to be using 24 volt DC coil on it. This relay is going to be tied to the e-stop circuit. So when the e-stop is out and everything's normal, this relay will be energized. Which leads me to the next thing. Centroid has a bunch of schematics on their website. You can download it. Don't know how well you can see that, but you see the all-in-one DC on the left side there and all the wiring diagram. I mean, this is it's typical. There's things on it that I won't be using, like the transformer for servo power. We won't be using that because I don't need it. It's got a relay for flood pump. So if you have a flood coolant pump and it exceeds the contact rating, or it's 3-phase, or it exceeds the contact rating of the all-in-one DC, then you would want to use the relay output of the all-in-one DC to drive the power relay for your flood coolant. So we're armed with the schematics. I downloaded the schematics that I'd need, and I went to let's see, Office Max or Office Depot. Either one of them can print these out for you. I think it costs like $5 for a sheet. And I printed them out in color because Centroid color codes their connections on their print, so it makes it easier to see. And I'm going to try and stick with that as much as possible. And I'm going to stick with their recommended wire sizes for control circuits and other power circuits and so forth. We're going to try and stick with that as well. So I'm going to go ahead and get started mounting this stuff up on the back panel. The back panel is a bolt-in, so I want to put everything on the back panel and wire it up as much as possible and put it in. I'm also got a main switch. It's a main switch. This one's a 3-pole. Has 3 poles on it. Won't need all 3 poles. I could actually use just 2 poles because I'm going 240 volt single phase input here, and then a 110 volt circuit for the all-in-one DC controller. So I actually have 2 circuits. I have the 240 volt and I have the 110 volt circuit that will be coming through for the all-in-one DC. It's just easier to do it that way. Otherwise you have to have a transformer that'll step down 240 volts to 120 volts. And my shop has both, and I have them right nearby, so I'm going to have 2 circuits. A 20 amp 120 volt circuit for the computer and the motion control, and then I've got a 15 amp 240 volt single phase circuit that'll run the variable frequency drives. So that's the way I chose to go. I'm going to probably mount this little guy. I'm going to cut a hole in the side of the cabinet, kind of mount it up high where it comes through the side. It would be easier for me to reach in there and turn it on and off. For service, I may opt to put a start stop relay in there as well, so that I can just push a button at the operator console and start up the machine and push a stop button to power it down. And then this will be a safety switch where I can shut everything down if I've got to work inside the control cabinet. I haven't decided yet. It really depends on how easy it will be for me to get in there and just flip the switch to power everything up. But like I said, this switch has 3 poles, and then it has a single pole on one side, single pole on the other. So we'll bring 240 volts into the main part of the switch, and then we'll run the single phase on the other side. You don't break, at least I don't break neutral circuits, so the 120 volt hot will come on one side and go out the other, and this will be a spare, and then there'll be a spare on the relay. I bought it off of eBay, so that's the way it's configured. Technically I could have gotten away with just the 3-pole switch, and I go at 240 volts on one pair, and I could put the 110 volt on the other contact and be just fine. But it's there, we'll use it. I'm on a budget, I'm a hobbyist guy. You guys, many of you might be too. So I did a lot of scrounging to save a few bucks. I'm trying to track the costs of this whole project to give you a realistic idea of what it costs to upgrade your mill to Centroid all-in-one DC. I mean, you've got the cost of the all-in-one DC unit, which is pretty competitive given what it is. I bought new variable frequency drives. The mill had a Hitachi SJ100. I just went ahead and got 2 new ones. I bought these from, I think it was Dealers Electric. It was a pretty good deal. And the cabinet actually came from Zorro.com. I believe I paid a little over 200 bucks. And the neat thing about Zorro is usually they pick up the shipping over 50 bucks. So when something this bulky, you need to buy something this bulky, Zorro is a really good place to go. I do a lot of my buying of things on Zorro. I'm pretty sure that Zorro is an arm of Grainger, but they've had some phenomenal pricing, so I enjoy using Zorro and the pricing I get from them. So anyway, let me get started, and I'll get the stuff bolted up onto the back panel. We got wire way to put in it. I've got some of those. I think I bought that off of eBay as well. It was a good price, just to kind of keep things neat. So I'll bring you back as soon as I got everything bolted up. I mean, I'm not going to bore you with bolting, drilling, and tapping and screwing things down. But I'll bring you back when we got the main components on there, and then we'll make a decision about the wireway. So stay tuned. It's kind of getting exciting because I think once we get this cabinet wired up, I still got to put my new limit switches on the mill, but that won't take too long, and we'll do a video just on that. It's pretty simple, straightforward stuff. But once we've got it wired up, I think we'll be ready to run the mill. So it'll be neat. It hasn't been run in about 2 years. I had a move, and she's been sitting for a long time. And I decided to go with the Centroid all-in-one DC retrofit because the machine was in such good condition. I thought it deserved a really nice retrofit. So anyway, I'll be back with you shortly. Okay, I've gone about as far as I want to go today. It's getting late, getting tired. And here's what I've got so far. I've got the power capacitor mounted and the bridge rectifier mounted. I got the 2 VFDs mounted. I got the power supply for the all-in-one DC mounted. I've got a strain relief here mounted so that my cables can come in, and then the encoder cables can plug right into all-in-one DC. Motor cables can come up here and get landed on their respective axes terminal blocks. And then over here, any of the limit switches can come up this way and land into their respective spots. And lube pump and coolant pump, we can probably get them squeezed in on this left side of the strain relief, the cabinet strain relief. That was pretty nice. I've got pictures as I was cutting it in. I didn't have a drawing to go by, so I guesstimated. I made sure that the opening was big enough to accept the DB9 connector shell, which is the slot is about 3/4 of an inch. And then overall the bracket is 10.5. I made the opening 10 inches so that it would be sealed up when the strain relief bracket is tightened up. I went with putting the power supply for the all-in-one DC up above it so I can get to it. If I ever have to service it, I can take it out. There is a lot of space underneath the all-in-one DC. It used to be that they used PC power supplies for them, and they've gotten away from that, and they've gone to these Meanwell, I think it's a quad power supply. What I did so I could see it is I wrote on the cover here, 5 volts common, positive 12 volts, positive 24 volts, negative 12 volts, earth, ground, neutral, and power, so I can see it without having to try and crane in around the side there. I'll bring you up a little bit closer so you can see it. I've got my disconnect switch mounted up here. I've got a little room here for contactor or whatever. There's still quite a bit of room on this side of the unit. I wanted to try and keep the VFDs and the power up above and separate as much as possible from the low voltage stuff. The VFDs, their terminal blocks are right here. I will probably come in through the top for the spindle, and I'll come out likely out of the side here of the cabinet for the knee raising and lowering motor, because that's where the cabinet is on the knee mill. But I'll get the cabinet all mounted up and then decide where to punch the holes. Power will probably come in right above the contactor, or not the contactor, but the disconnect switch, so that we can go right into the disconnect switch and then come out to feed everything. So yeah, that's where we're at. So the cabinet itself I think is all cut up and ready, and I've got the major components on there. I need to study these electrical schematics for the all-in-one DC so I can decide, you know, what else is going to go in here. You know, I know I've got an e-stop contactor, might be another contactor, so maybe DIN rail here with terminal blocks to land things on. So I've got to do a little bit more pre-planning. Looks like I might have some dead space here, but we'll see. How I cut the openings, I use a unibit. It's a step bit, very handy for cutting the larger holes. I use the unibit on either side of the strain relief bracket so that the slot is kind of a long oval with rounded ends on it. I think it just looks cleaner and a little bit nicer. So I'm real fan of the unibits or the step drill bits. And I filed everything, all the sheet metal, I filed everything. I deburred every screw hole on it to make sure that there were no sharp edges so we wouldn't catch the cables and so forth. So yeah, I think I made good progress for, you know, I think it took me, I probably worked on it 4 hours today, just kind of taking my time and thinking things through and doing things right. So anyway, I think it's looking pretty good. So next video installment, I'll lay the wire guides in and get any DIN rail and terminal blocks in, contactor if I decide to go that route, get that in there, and I'll show you that.